Welcome everybody to SQL Friday. This is SQL Friday number 29 already. And our star of today is Uwe Ricken, who is closing out the season, we should say. I'm working on session selection still, or rather scheduling for the next half year. The call for speakers is done, so I'm just stay tuned for the announcement of next year's schedule. But today, Uwe Ricken is here, and he is going to talk about simplifying data management with partitioning. Uwe was the first pre-con I went to for SQL Saturday was in Gothenburg when Uwe was doing a performance tuning workshop for a full day. So I'm really looking forward to hearing what you have to say today, Uwe. The stage is all yours.
Okay, thank you very much. So then I will start sharing my screen. Thank you first of all for the introduction. I'm really happy to do this session nowadays. The last one this year. So therefore I'm really grateful that you have selected me. And my topic is about SQL Server in conjunction with partitioning. So the general session title is Optimize Your Data Workload and Your Data Management. And before we start, let me say a few words about the demos I'm doing and what you can, if you want to replay them, you have the possibility to download my demo databases. I have a very big one, which I normally only use in my workshops. So here I will use the smaller one, the customer orders database. And if you want to have the slide decks and the demos, then you can download them with the short link here, bit.ly partitioning for data management. So just only a few words about me. Forget about all the commercial things here on the left side. It's not so interesting. The most interesting thing here is my email address. So if you have any questions concerning this session or anything database engine related, just feel free to drop me an email and I would really happy to help you, to assist you. So just a short note, better is 2 notes. First of all the use cases I want to demonstrate here, it will be 2 or 3, depends on the time. All the use cases which I show here in this session are based on real world scenarios which I have found when with my company engagements, and all these solutions went into production to help the customers. The customer scenarios have been for sure simplified for this session because I want to focus on the problem but not on the whole environment what normally goes with this kind of problems. And the last thing is that my CPU currently, due to the fact that I'm running Teams, is heavily under pressure. So if you see that the results, let's say, will not expect, let's say, 20 or 30% improvement of the queries, it is because of my CPUs. I'm just running my demos here on a small notebook with 4 cores. And it could be that we have just only an improvement of 2, 3, 4%, but that's okay. So here comes the reason why you should use partitioning. I think that most of the people, when they think about partitioning, they have 2 ideas in mind. The first is improvement of queries. By the way, that is, from my point of view, should not be the main reason to have partitioning. And the second one is more focused on DBAs, and this is the last demo I want to show you, when they come to SLAs, service level agreements. Think about the situation that you have a 15 terabyte database and your business is telling you that the database must be online, let's say in 15 minutes. Due to physical limits, it is not possible. But yeah, there is a good idea to use partitioning in this case. Here comes the first scenario. That was a customer from automotive where I was engaged with. It's a high transactional production environment. This customer, what I describe here, is working in a pharmaceutical company, and they are producing drugs on various product lines. And every single product line has to check the drug, and they must go through a Q&A. quality assurance, check that store the data in the SQL Server. My use case will describe 16 different product lines, and all these product lines have different drugs they produce. And they have one or more web servers which were monitoring the machines, and all the so-called telegrams about the quality were catched by the web servers, and the web server were pushing the data into the SQL Server database. The problem they had were that, let's say, when they started the production, at least 2, 3, 4 hours later, they had a big waiting queue on the web server that the telegrams were not getting too fast into the database. And that was the challenge what we wanted to improve. So here you see that the web server on the left side is filling a table. There is a machine ID, the sequence ID, a timestamp, and the column C1 is just the telegram data. And the database from the vendor was so designed that they just only had one file group and just only one file. So the data were permanently written into this one file, so from the transaction log into the file. The data in the queue grew because SQL Server could not save the data quickly enough. They were coming hundreds of thousands in a few minutes. What we detected were latch contention. Latch contention, that was the main problem here, that SQL Server or that the processes had to wait. The third point that was, by the way, by default with this implementation, that the indexes were severely fragmented because the machine IDs were different with each process when the data came in. So, and this is something what we want to cover or want to improve by partitioning. So here comes my demo, and I really hope that you can read everything, that you can read the letters, that it's big enough. So you can download these demos. I create my demo database. I have another query which I want to use here, and then we can start. So the script 0010 describes the situation. What will I do? The first step, I create my demo database, and in my database, I create a very simple table, which contains the machine ID, just only the timestamp, and the workload, which is the character 1 kilobyte. So this is my basic system. And afterwards, I create a clustered index on my machine ID and on my timestamp. So here comes my workload. Very simple, very easy. I just only create a stored procedure which is permanently filling or is inserting data into the table. You can see here that I do not anything else in between. I just only push the data into the table. Okay, now we can start. And to see what problems we will have, I want to implement an extended event session which covers the page splits, which I have, and they cover the latch contention, which takes more than 100 milliseconds. So for the people who don't know what a latch contention is, think about a latch contention as a problem when 2 or more processes wants to get access to one resource in the SQL Server at the same time. So the resource, which is mentioned here, is a data page where we want to put the data in. So what then happens is they are queuing because everybody wants to read on this data page. And when they want to catch a lock on it, then they get a so-called latch on it. It's a page latch. And the latches are internal blockings, internal locking mechanism. And this is something what I want to make visible here in this scenario. So therefore, what I'm doing is I am implementing this X event. I have scripted it because it was easier to click around here. And here, let me check one thing that is really important that failed in the last demo. I need to check whether my database ID is the number 5. If not, then we don't see results. Oh, you see, it's the number 10. Okay. So then, it's here, perfect. It's okay, so number 10. So I'm covering everything from number 10. So what you can see here in my management, here is my extended event sessions. And what you can see is that my extended event for high transactions will store everything in an event file. And then I will run a query against this to figure out what's going on here. Good. I reset my weights. And then what I'm then doing is I want to produce workloads. For the workloads, I'm using the RML utility OStress. So if you do not know what it is, I want to show you how this works. What I'm doing here is I'm starting my program OStress. That's a Microsoft tool which you can download from Microsoft. If you're a developer, I strongly recommend to you, if you are planning to develop high transactional systems, just use OStress. That gives you a so great opportunity to push workload on your database that you can see whether your database is scaling or not. What I'm doing is I'm processing now 16 simultaneous processes, all run the OStress tool, and then they are firing my store procedure, everyone with a dedicated machine ID. So that simulates every single machine. I do it in my demo DB and I repeat the run 10,000 times. So every single machine tries to push 10,000 records into the table. That's what I want to run. And therefore I have prepared this. So just go for this and run my command tool. And here we are. So now the system starts. And the system is processing now 16 machines, and only 16 machines are now pushing the data into the table. And we need to wait a little bit. And afterwards it will come a little, it takes a little while, up to 30, 40 seconds for running this process. And always keep in mind that now 16 machines try to push the data into one single data page, and that can take a while. So let it do it in the background and I will go ahead here. So what I'm interested in is for this workload now, because SQL Server has now recorded the wait. So what is it waiting for? What I want to see is how often did we wait for a write log, that we write the data into the log file. And here you see the ledgers. So for exclusive access, I want to write. And for a shared log or for a shared access, which means I want to select data. And on the other hand, I want to see how my CPU is going on, but that's only for me a private interesting thing here. So I run this query. Let's see whether it's finished. Oh yeah, it's done. And now please have a look to the result. And that is really interesting here. You see that the first one has finished in 41 seconds. Keep in mind that every single process is pushing exactly the same data into the table. But what is interesting is here that we have a variety of different runtimes. So this one was finishing in 41 seconds, while this one was finishing in 46 seconds. So it's 5 seconds more. And the question comes up, what is the reason for that? Let's look into the internals of SQL Server. And here I'm running an analysis about the wait stats. First thing, what is really good for this kind of workload is we are heavily writing data. That is so far okay. The second one, as I told you, my CPU is extremely under pressure, and that is something what you can see here. My waits are 5 milliseconds to get back to the queue, to the CPU. But here comes the very interesting part. You see here that I have page ledgers, page ledger for exclusive log and page ledger for shared log. This one is with the IO, does mean that it was from the disk, but that's okay. But I see here that we have latch contention. And now have a look to the index. And if you look to this, you would say, oh my goodness, what's going on here? So we have 160,000 rows in the table. We are consuming 22,800 pages, but have a look to the fragmentation. So if you run analysis over it, because the quality check they want to analyze, we have a completely fragmented index here. The average disk space used is 90%, which is from my point of view, good value, but it could be better. So let's see how often Microsoft SQL Server was covering a latch contention. So what I'm doing therefore is, here you see my extended event, and that was writing into an extended event file. What I'm doing now is, I'm now crunching it and get the XML data out of it, and then I can run my analysis for this. Let me run this script. Takes a little bit because we have monitored lots of these events, and look to this here. The very important thing is here that we have lots of locks or latches on data pages. The boot page is not so interesting, but look to this. Look especially to the average duration we have here. And the problem is, and that I think everybody can understand, is that we have 16 machines and they all want to push the data at the same time, but just only one can write. So we have to wait. And the average wait is here around, on the GAM page, 6 milliseconds, 9 milliseconds for an update. Oh my goodness. These are horrible values for a high transactional system. The question is, what can you do about this? We have two problems here to solve. First one is that we are covering very high average durations on every data page. Second one is that we are suffering from a bad index performance because it's highly fragmented. So what can we do here? The key point is that we have 16 machines. And now think about the workload. Every machine is pushing the data to the database, to the table, and there, when 16 come at the same time, they all want to write in the same page. Or what we have too, because of the high fragmentation, is that we have hundreds of thousands of so-called bad page splits. Let me show you the page splits here. This comes from the event session, by the way. So it takes a little bit. You see that there are lots of page splits here. And a bad page split for me does mean that when I want to have a new page, which is a page split too, when it is directly after the one I'm accessing, then it's a so-called good page split. But if we have a gap in between, then for me, this one is a bad page split. And now look to this. We have 21,000 page splits for this first workload. A page split consumes lots of transaction log because it doubles it, because we need to move half of the data page to a new one. For example, when I want to insert something in the data page 143 and it is full, then SQL Server is moving half of the page of the data from this page to the next one, and this is the number 213. That means that our transaction log has to cover 4 kilobytes for the transaction log on top of it. Yeah, and this is something what we want to avoid. How can we achieve this? First thing, I need to make sure that with the next load, my transaction log is my trace file is empty, so therefore I stop my session. Then I delete my data and restart this. Good. Okay, what can we do? The key point here is that I want to have name it a channel. I want to have a dedicated channel for every single machine. So whenever a machine is pushing data into the table, I want to make sure that it has its own dedicated database file where only data from this machine gets inserted. And this is something what can be perfectly, really perfectly be achieved with partitioning. And that's what I want to do here. I empty my table. Now I make my database a little bit more flexible by inserting now for every single machine its own file group. And for every single file group, I only create just one file. So that's very easy. It's done. You see here my statement. I say, please add a new file group called machine1, and then please add a data file to this file group. And this I'm doing 16 times. So here is the layout of my database. Properties. And by the way, it's a very good approach to do that. And if you have a vendor who say, oh no, we can't use partitioning, we didn't test it, or something like that, it is not a problem to partition your tables because it's completely transparent to your application. The only thing what could happen, or where is absolutely a veto from the vendor, is when they say, oh, no, we run update scripts, which do not cover partitioning. Then it's a valid point. So let's have a look to my layout now. You see here in my database now I have for every single machine its own file group and its own database file. So far, okay. So now comes the implementation of partitioning. This is not an introduction to partitioning. I would expect that you know how partitioning works, but in very easy words, I now need a partition function which can distribute the data, and I say please have a partition function called machine ID, and then I distribute my data from machine number 1 up to machine number 16. This is the logical implementation, and now I need to have a, let's say, a physical binding between the table and the partitioning infrastructure. Therefore, I create a new schema, partition schema, which has now for every single machine, I mentioned what file group it has to use. Yeah, so this is my partition function, and I say when I write the number 1, write into this partition 2, 3, 4, and so on. So I implement this, and that's it. It's done. The only thing what I need to do now is I have to recreate my index. I cannot do it by rebuild this. I have to drop it and then put it on my partition schema. And I say that the distribution of the data is depending on the machine ID. So far, so good. Now I clear my weight stats. What I want to show you now is the following. You see, by the way, now it's time to learn a little bit of German language because my OS system is German, but however, it's quite easy to understand. You see here my storage activities. And what I'm doing is I want to filter out everything what my SQL Server is doing. This here is, let's say, the rest of my activity before. It's not so important. Please have a look here to the right column. So that's that will be active when I start writing my data. So just go over here. It is cleared, perfect. So now I start, make sure that it's started. Okay, it is. Good. And now I start my session again. We are. Same workload, same method. And we are starting 16 machines, and now they are producing bang, bang, bang. Every single pill is going over the belt, and it's running. And now have a look to this. What you can see here that we now have a perfect write activity here. You can see my log file, that's okay with it's 8 megabyte, but the key point is that I'm now heavily writing into my dedicated machine data. So every single machine is now pushing its own data into its own dedicated database file. And that is a very great opportunity, and I would expect here now, but as I said, it could vary a little bit, but have a look. Oh, very cool. You see this? We are nearby, in average, under 40 seconds. So we have definitely have an improvement of 4 to 5 seconds by writing the data here. And that is a great improvement what we have here. But we need to prove this. The customers see, well, yeah, it is working faster, but can you prove it by evidence? And I say, yes, I can do so. And here we go. And the first thing what I want to check is my weight stat analysis. So I go for this and have a look to this. This is, from my point of view, the first absolute evidence that we have made a big improvement. You can see that my write log activity, which was the mandatory weight stat before, has increased from 75 to 95. And another big issue here is, do you see here any page ledge weights? To be honest, I don't see anything here. The reason is that every single machine has its own dedicated data space, and no other process is disturbing this. And that can be really perfectly seen by the index fragmentation. Go and look to this. Is this cool? So we have the average, that's okay, but have a look to the fragmentation. Absolutely nothing. There is really no fragmentation in it. And the reason is very simple. We are pushing by machine and timestamp every single row, sending insertion of data, and that's perfect. Have a look to the ledge contention, and that is something what I want to see too. So I stop my X event and run the query again for having a look to the ledge contention. I run this. Let's see this. Takes a little bit, but here, ta-da. When I see this, I get a big smile in my face, because now I know that the customer will really be happy to pay my invoice. We have an absolute improvement in our system, in the loading process, by not changing anything in the software itself, or we didn't throw hardware on the problem. We just only made a little architectural design change, and that had made these big improvements. Have a look to the page splits. It can be, but then it's just only because of my query. I would expect here just only a few of the change. Yay! Just only 2 bad page splits, not 21,000. And this, to be honest, is exactly the thing I wanted to have. So you see that partitioning is not only for improving, or is something where you would say, oh, I use this for better query performance. No, absolutely not. Partitioning is something what you should always take into consideration when you have highly transactional workloads. So here comes the solution. What we did was, we have created for every single machine its own dedicated file group. I will show you in the third demo why it, from my point of view, is quite important to have different file groups. And every single file group has its own file. And here comes the very good thing, and that makes your database way more scaling than expected. Let's say your customer has 16 different machines, but every machine has completely different workload scenarios. Let's say machine number 15 is pushing the double of the amount of data into it. You know what you can do? Just only put another file on it and distribute the writing on 2 files. And I promise that will be faster then. So, and that gives you so much improvement and so much possibility to scale your workloads just only by changing the underlying infrastructure of your database. We had an performance improvement. It was depending on the machines from 3 to 10%, and the main goal was reached that they didn't have any waiters in the queue on the web service. It worked like a charm. It works like a charm. And another good thing is when they want to add a new machine, no problem. Just add a new file group, put a file on it, and it works. Change the partition schema and the partition function, and then we have the next machine implemented in. Very, very easy. So the distribution of the data by machine, we have reduced the page latch locking duration and the number, by the way, and we had a way better throughput if data files are on different storage. So if they say, oh, one machine is working quite heavily, they say, well, put a flash disk on it. Janice Fernandez will definitely be happy if you would take a pure storage. And the last thing, and think about the maintenance, we didn't have any more index fragmentation because every machine has its own separate partition. So that was one of my biggest successes, and I was so happy about it that I said, wait, make a session out of it. Use cases for partitioning number 2. Oh yeah, that was quite interesting, and this is from a customer from me, which is running the biggest supermarket chain here in Germany, Europe. The data warehouse problem they had. My customer is a retail company that load the key figures, so product and sales of product, of all cash registers per site into the data warehouse, and they're doing it every single night so that they can create reliable plans for supplying the supermarkets. And here we have to think about the following problem. They have way over 3,000 supermarkets just only here in Germany, 3,000. And every single night when the market is closing at 10 p.m., the cash desks automatically will push all the data they have onto an FTP server. And from this FTP server, a process is going and is bulk loading the data into the database server. The problem is that the whole workload and analysis needs to be finished just only by region, latest at 4 a.m. in the morning. The problem they had that by growing data and by growing number of supermarkets, they didn't reach this gap that they could say, oh, we were finished at 4. The point is they need to be out, they need to finish it at 4, because when the trucks were coming and pushing the products to the supermarkets, they normally started at that 5 o'clock, for example. So what can we do here? Let me show you this example, and this is my demo number 20. Speed up your data warehouse workload. I will close everything here down. We go to the number 20. And here we go. First thing what I'm doing is, so I don't have an FTP server, so I put some test data in a staging area. So I create my demo database. And what I'm doing here is I'm creating a schema called staging that I separate the pure data from the analysis. So I go into my demo database, create my schema, and then I create 2 tables. The first one is the cache activities. And here I fill a few randomly generated data into it. That takes a little bit because we have here, just only for this demo, around 9 million rows, which are now gets generated from a demo database. So 9 million rows are in. Now I create a clustered index per warehouse ID, so per supermarket, and per every single separate cache desk. million rows, that's easy. Come on. And here are my data when it's finished. You know, it's becoming very hot here in my office because my CPU is so heavily burning here. By the way, if you want to have a look to this, here is my heating. Yeah. So, oh, it's 51, but I promise it was 100 a few seconds before. So here is my distribution of data. Each warehouse and every cache desk, you see the number of entries I have, and you see that they are quite different. So for us, most important here is that we have different warehouses, and every single warehouse could have from 1 to maximum 25 cache desks. So that varies a little bit. Now I create the second table, which is the cache analysis, which give me which they want to use then for the planning of shipping of the food. Now, what I'm doing is I create a third table. This table just it only logs when we did start the process and when did we finish. Nothing else. This is only for us to see how long each process took place. And here is my simple, very, very simple store procedure. What will I do here? This store procedure, I hand over a warehouse or a supermarket ID, and then this store procedures will covering, hey, how many cache desks does this supermarket have? And then we go for every single cache desk and write data into the warehouse. Let me see, here it is here, into the cache analysis. When we have finished so the whole supermarket, then we update our recording. So how long did it take? And that's for me that I can see how long it was taken. So now I clear my wait stats again. And after this, I run again another workload, a different workload. And let me show you what I'm doing here. Very easy. The same procedure as every year, I would say. So I start my load process for 16 warehouses again. So that means I start stress, and it's exactly the same workload here. You see that I'm connecting to my machine. I run this start procedure for every single warehouse. Warehouse 1 up to 16 in my demo database. And this time I do not need to repeat this because the store procedure will do it by itself. Only thing what I say to the system is, please make it quiet, please. I'm not interested in anything or in any output here. That's the -Q statement here. So that's what I want to run. And it's prepared here. Copy this. And I go back to my command window. So that's done. Let it start. And now my 16 warehouses get filled. And it might be that you will see that few of the warehouses will finish way earlier, but that could have two reasons. The first reason could be that they have not so much cache desks. The second reason could be that they have finished earlier. So here's the first one. Yay, 18 seconds. And you see that it comes step by step. 21 seconds. Yeah. Oh yeah, here at 26. And you see 3 seconds and 5 seconds difference. And it's growing and growing and growing and growing. And that is exactly the problem they had too. So as more supermarkets, they put into the progress queue as longer the system was taken. And the first thing what they were mentioning was, yeah, put money on it, give it a better storage. But they had wrong fast running storage. We didn't see a bottleneck on the storage. So that was something what we were really wondering about. So we said, I wouldn't do this because your storage is running perfect. And shit, I did a little mistake, but it's okay. We don't see anything blocking here. Yeah, okay. However, let's see what were SQL Server waiting for? And you will see nearby the same problem as we have seen in the first one with a small difference. Look to this. The system was permanently, really permanently waiting to gather a ledge. And this was taking in average 0.4 milliseconds. It sounds not very much, but it is exactly the same as when I tell you, what is a minute for you? And then, or if you ask me, hey, what is a minute for you? I say, it depends on what side of the toilet door you're standing. So, and this is exactly the same problem what you see here. Look to the huge amount of weights we have here. It's over 1 million times where we're just only waiting for, well, I want to write. 1 million times. My goodness. And this is something what we definitely need to figure out what is the problem here. Let me see how long it was taken. And you see here that, for example, the warehouse number 6, that was incredibly fast. It was 16 seconds, but then it is growing and growing and growing and growing, and so on. The difference between this kind of workload and the first one is that here we are pushing lots of data in one process into the table. And if we have more than 5,000 rows we want to push into the table, then we run into a very extreme ledge contention because SQL Server will escalate the lockings. It will then at that moment will not lock only just one page. There is another one who wants to insert the page into me. No, the record into me. No. It's locking the table. And exactly this is the problem what we see here. Yeah, so let's say the first one is hitting the data, and while it's pushing the data into the table, the next one had to wait, and this one had to wait, and all 15 others have to wait, and then this one was finished. Okay, now the next one could push the data, and so on. And this is the problem we have to improve here. And you will see that we can do exactly the same with partitioning here. This is just another information. The max was 60 seconds, 16. In average, it was taking 44 seconds. Ooh, very, very, very long. So, okay, we truncate the table, empty it, and let me show you once again what happens inside a transaction if we import just only one warehouse. I start my transaction, so it's taking a little bit of time because now it's, oh, that was incredibly fast, 2 seconds. But to this. And think, by the way, now think about that there are 15 other warehouses and they want to do exactly the same. Have a look to what object my process has blocked. You can see that on the cache analysis, so that the table where we put the data in, there is an exclusive lock on it. And that's the reason why the warehouse number 2 is saying, well, Mr. Warehouse number 1, can you please finish because I want to insert my data too. And while I'm just talking about to you about this topic, nobody else can write into it. So that is the biggest problem here. So I run a checkpoint to clear my log file. So let's see how we can improve this. Here is one very simple, tiny change or difference between this demo and the first one. I want to show you what I mean. First, again, I create for every single warehouse its own database file. Come on, and file group. So it's done. Let me check if everything is fine. Here it is. You see, for every single warehouse, I have my own database file. And then I create my partition function, which has every warehouse in. Then I create my partition schema. You see, it's all the same. And I promise you, if you might think, oh my goodness, partitioning is so difficult, it's so much to type and so on. I just promise you, it will be the first, the second, maybe the third time, a little bit problematic. But I promise you, if you do it the fourth, fifth, sixth time, you will not think about it because it's so easy. So did I run this? Yeah. Okay. And now I create my clustered index on it. So here is the summary. Come on. And you see here that now my table has the index on every single partition. It's empty. And now comes one point which is very important. I will do this here because I will skip the first one. Normally, if I would not run out of time, I would run exactly the same workload again, and you will see there is no improvement. Absolutely none. It will be, and I promise, you have to trust me, it will be nearby exactly the same. And the reason is that when you work with partitioning, you have to make sure, especially when you're dealing with the problem of table lock, so lock escalation, you have to make sure that you tell SQL Server for this table that it should use, and I'm wondering why it doesn't do that, however, the lock escalation set to auto does mean that when SQL Server need to run in lock escalation, it will not run a escalation on the table level, but it will do it on the schema level, on the partition level. So let me show you what I mean. I changed this. It's empty, I know this. So I begin my transaction just as the demo to show you how it works. I run again my warehouse number 1 and have a look to my table. Do you see this? It's an intent exclusive lock. So that does mean if a second process is coming in, it can force an intent exclusive lock in the same way. So, and then we will have down, somewhere here, I don't find it so far, but there will be now on the partition an exclusive lock. And that scales like a charm. I roll it back. I reset my perfmon. Come on. And then I run my query again. But while it is running, I want to show you for what is SQL Server waiting. And what you can see here is, we're not waiting for anything. So nothing. This is not a fake. I'm not waiting here. You don't see waits on the partition or on the log or something like that. No, nothing is waiting here for anything. That does mean that now my workload will be more consistent. Have a look to the numbers here. You see that instead of 1 minute, we have improved our performance with the last one by 50%. And now you can see that all the numbers are nearby. Oh, by the way, nearby the same. So we are telling here that we are around, let's say, 20 seconds, 20 to 24 seconds. But this is way better than waiting a minute. And my analysis proves me right. So when I'm looking to the wait stats, you remember page clutch X was the number 1, but now look to this. My number 1 is, but that's because of my little tiny small laptop here. My number 1 is my CPU, but not even more of the page latch. And here you can see that the write log then, that is what I want. I want to push the data, and that is one of the favorites here. So that's exactly what I want to see when I'm dealing with workloads. So let's check the weightings, the different weightings, and you can see here that we are now 17, 22 seconds, 25 seconds. We are now incredibly fast. And the max is not even more 16, and the average is not 44, but now it's only 50%. And that brought back the analysis approach they wanted to have because they wanted to finish at 4 a.m. With this approach, they were finishing around 1.5 hours earlier. So the next one I will skip here because I wanted to demonstrate it with column store indexes. But by the way, if you have very small number of rows you want to insert into a table in a data warehouse, I would not recommend to do it with the clustered index, especially when you're dealing with time critical processes. So I skip this. Last but not least, the next thing, and this I want to skip here, I want to go for this. I hope that a few of you guys are DBAs here, and I furthermore hope that you have sometimes the problem that you will have big databases, and let's say your customer is telling you, well, I need to have it done when I need to restore in 15 minutes. Ho. To be honest, that's a challenge. That's absolutely a challenge, and that doesn't work. There are physical limits which you cannot cheat here. So let me show you how you can improve as a DBA to cover your SLAs by the business. The most important thing here with this scenario is that your customer needs to make sure that he understands that you will divide the database between hot data and cold data. So let's say there is a data warehouse, 15 terabytes, and one customer here in Germany, and I learned lots with data management from him, because his data warehouse is nearby. It's not a joke, it's 48 terabytes, 48. And this is incredible. I never was dealing with such a big database. I know maybe a few of you do, but that was the first time for me. And so the problem is always the restore. Backup is not a problem, but the restore. So we explained the customers to the business, to the business, okay, let's say we have 10 years of data in it. What is the number of data you want to have immediately accessible when the database is up and running? And let's say he's saying, well, give me the last 3 years. Then the luck is on your side. Let me show you why. This is the script number, or let me check. I think it is piecemeal here. Number 43rd demo. Again, I create, but this is going now very fast. I create my demo database, push 3 million rows from different years, from 20 years into it. Here we are. Now I make a partitioning, I implement partitioning. You see it here for every single year, beginning from 2000 up to 2019. Then here it is, I separate, I make the preparation to have every single year on its own file group. By the way, that is something you really need to have, otherwise it won't work, because we want to restore different file groups. That's the point. Here is my partition schema. That's done. And now I run a partitioning, or I start the partitioning for this table. So 3 million rows are now separated on 20 years are separated on 20 different file groups and files. So refresh. Here is my demo database. If I look to this, you will see here are my dedicated years. Okay, here comes to the next point. The customer wants to have at least the last 3 years. In my example, this is just only 2 years, okay? So 2019 and 2018 should be available for the customer, available years when he is doing his report in the morning. So here comes the trick. When I know that all the other years will never be touched again, question to you, why do not make them read only? This helps you very much. I do this. So now my file groups have set to read only. So every single file group, 2017, 2016, and so on, they are read only. And you can see it here. This is my result. See? Perfectly. Read only, read only. And here at the 2019, oh, I'm wondering, okay, yeah, the 2019 is the actual one. But you see that here is the problem. I need to put away this one. Okay, however, so 2019 is available. So now I run my backup. Okay, go for it. It's a big database. And now it comes to a disaster. The database got crashed. So you're in the morning, 7 a.m., you come to the office, you grab your coffee, and then suddenly one of the businesses coming to say, hey, Uwe, you have to help me. You have to help me. My database is down. And you know what the good thing is? You're standing right over there with your mug coffee and say, keep cool, babe. I run it for you. Yeah. So what can you do? Because you could be so relaxed. The SLA defined that you just only have to, that the last 3 years should be available. So in my example, it's just only 1 year, but it's the same with 3 years. You sit down very slowly, laughing to your customer. He's standing there, he's sweating, saying, oh, I need my data, I need my data. And you say, keep cool, look to this. Just a very simple statement. Restore the database from the last backup, and please just only restore the read and write file groups. Just one click away while you're sitting there relaxed in your chair, sipping your coffee, your database get restored. Refresh. And you now can turn around to your business colleague and say, now go ahead and run your queries. But keep in mind, just only the last 3 years. Let me check how it looks like. So internally, so while he is walking back to his office and starting reporting services, you check the situation and have a look to this. Here is my primary, that's okay. That's my log file. And you see that all the others are pending, recovery is pending. So they are not available, but have a look to 2019. Oh my goodness, it's online. It's online, so he can run his query. Let me check if we can do this. So we run this query for 2019 and see it works like a charm. So in the meantime, while he is doing his queries for the report, we need to make sure that this customer understands that he cannot run this kind of queries. He can just only run a query against the partition key. So if I try to do this, I will get into an error because the number 10, it is not guaranteed that it is just only the 2019. So whenever you run a query, what you need urgently, you always have to have the partition key in your query. Otherwise, it won't work. And this one won't work too, doesn't work. But now what we do is we now very relaxed restore one after another file group. So you see here, now it's working. So one after another is going to get restored. And the good thing now is you can stay at the phone and say, you can run your query against year 2000. You can run your queries again 2005. And now 2007 is in progress. It's done. Go to 2008. Yes. Nearby, finished. Just only 5 more and then we are gone. And you know what the good thing is? My restore is finishing exactly in time because now 60 minutes are over and my session seems to be finished now. And I really hope that you have enjoyed the last SQL Friday session in 2020 and feel free if you want to have some questions, just please ask me this question. Thank you very much.
Thank you so much, Uwe. We had one question in the chat, which was if a single file having partitioned index based on multiple machine ID can also improve the performance in case of reads, but may not improve writes. Is that correct assumption? So basically, if we partition on a single file, what kind of benefits do we get from that?
Okay, you mean that you will not run a partitioning on separate files, but just only on one database file.
Exactly.
Now I understand. That can be a problem, but that really heavily depends on the storage. What you will not cover, or what you will not see then with partitioning, whether you have one or multiple files, is you won't see the ledge contention. And as you have seen in my example, the ledge contention was in my case the problem, but not the storage. So if your storage is fast enough, then it would be great. Then you can do it with one file in the same way.
Yeah, and I think there is, I mean, it depends on the use case, of course. For me, when I have used partitioning, it's very often in kind of a load data scenario where I want my data warehouse to be online while I do my ETL, and then when I'm done with importing the data to my staging environment, I just want to switch it into the data warehouse. And it kind of relies on it actually being on the same file group as the partition.
Yeah, I have another example for switch in, switch out. But due to time lags, I was skipping that. That was the only reason, because I want to let me say it other words. I know that lots of data warehouse architects, developers, SSIS experts, they know about the feature of partitioning. But mostly I see that people are thinking about partitioning. Well, yay, I have a data warehouse. I can easily switch in, switch out, and that makes it so comfortable. But what I wanted to achieve with this session is I want to focus more on people who say with an OLTP system, mostly people don't think about partitioning. They say, why should I use partitioning? Partitioning is for data warehouses. And I said, no, it's not only. You can have it, as I have shown here with this with these kind of workloads.
Yeah, and I worked with a client that did, it was a basically phone company, so lots of transactions.
Absolutely, yes.
They earn hardly anything on each call, so they need to have millions of calls every hour. But they used partitioning with the old poor man's partitioning, where you create a new table and they create a partitioned view on top of the tables.
Yeah.
But the reason for that was they started with their partitioning back in, say, 2010, and they had standard edition. So it was only in 2016 we got the partitioning functions in standard edition. So
yeah, thank you so much, Magnus, that you have mentioned it. This is really important to know for all of the audience. I could strongly recommend go and use SQL 2016 or later, because with 2016 Service Pack 1, partitioning is for free. It's in. So you don't have to have an enterprise edition for that. Yeah, thank you for mentioning that. I completely forgot this. Yeah.
And many other cool features were included. Column store indexes used to be, it started as an enterprise feature, and now it's available. So I think that was a really, Service Pack 1 for 2016 was a really important patch or update.
Yeah, that is true.
But developers.
Yeah. But unfortunately, I have a few customers they are using column store indexes quite heavily. But the problem is a few of them think, hey, use column store. It's my silver bullet that solves all my problem. But that's rubbish. That's completely stupid. If you have an OLTP system and you're using a column store index, that can be incredibly slow. Maybe next year, so if I will submit, Magnus, and maybe next year I will show a few use cases for column store indexes, where it's good and where it's not good.
Yeah, to be honest, the only time I've actually used column store index is to force batch mode on a query that would normally run in row mode, and then that's a column store index with no rows in it.
Yeah, but you don't need it if you have 2019.
No, but who has that in production? Most people don't, or most
Oh, I
companies
have
don't
lots of
yet.
customers. Yeah, I have lots of customers. They are periodically changing. So one of the biggest customers I have, this is the one with the supermarket. They are slightly now changing to 2019. And
Good for you.
yeah, and well, banks, I know banks are, this is a nightmare. So before they take 2019, it's the same as here in Germany, our airport in Berlin. It takes 20 years for a bank to use SQL 2016 when everybody is in the cloud, you know. But then they start changing their on-prem 2000 server to 2016.
Do you know what the oldest officially supported version is of SQL Server?
I think it's 2014, but I'm not sure.
It is not. It's actually, you have 6.5 still being officially supported because there is one customer that is paying Microsoft to keep it under support.
Oh, really?
Because they can't afford to migrate to a newer version.
My goodness, they pay horrible much money for that.
Yeah, I think they're the only customer doing it. So it's I can't even imagine how many databases they must have for making.
But they will have so much problems for that. They do not have role locking. They do not have all these new cool features. But if the vendor will not update, then they are lost. You see, everything depends on the vendors, right?
Yeah.
That's true. Okay, Magnus, then I have to go in 20 minutes to my next meeting. Let me say to all of you a big thank you. It was really, truly, it was a pleasure for me speaking here, the last SQL Friday this year. I wish you all a Merry Christmas, a Happy New Year, and the most important thing is, please all stay healthy, that we all can meet again in 21. Thank you very much, Magnus, and all the rest, and bye-bye.
See you. Bye. See you.